Welcome to the virtual training course on Quality Control and Inspection Principles. This online training is designed to help you grow as a quality professional. You will learn the basics of QC, develop practical inspection and auditing skills, and discover how to apply them in real-life situations, especially in the Bangladeshi garment industry. What you learn. Lesson 1. Introduction to Quality in Textiles and Garments. Lesson 2. Principles of Quality Control and Inspection. Lesson 3. Fabric Inspection, Methods, Tools, and Defects. Lesson 4. Garment Inspection, Stitching, Measurements, and Finishing. Lesson 5. In-process quality checks versus final inspections. Lesson 6. Common defects and how to prevent them. Lesson 7. Handling customer complaints and continuous improvement. Lesson 8. Tools for quality control, AQL, checklists, SOPs, and more. Lesson 9. Quality documentation and reporting. Lesson 10. Building a culture of quality, training, audits, and improvement. Thank you for joining us. We hope you gain valuable knowledge and practical skills from this course. Don't forget to like, subscribe, and click the bell icon for updates. See you in Lesson 1. Welcome to the virtual training course on Quality Control and Inspection. In today's video, we will talk about Lesson 1. Introduction to Quality in Textiles and Garments. In this video, you will learn what quality means in textile and garment manufacturing, why quality is so important for both factories and brands, who is responsible for ensuring quality, some common issues that affect product quality, key quality terms you need to know, and the different types of inspections that take place in the factory. Let's get started. So, what does quality mean in the context of textiles and garments? In simple terms, quality means meeting the customer's expectations. This includes the look and feel of the fabric, the accuracy of stitching and fit, and how well the product holds up over time, such as durability and color fastness. But remember, quality is not just about the final garment. It's about every step of the process, from fabric selection to packing. For example, if you produce a shirt that fits well but has loose threads, uneven stitching, or fades quickly, it won't be considered high quality, and the customer will be dissatisfied. Why is quality such a big deal? First, it reduces returns and customer complaints, which saves time and money. Second, consistent quality builds your brand reputation and keeps customers coming back. Third, a strong focus on quality helps prevent waste and rework, both of which eat into profits. And finally, meeting quality standards is essential for international compliance and avoiding buyer penalties. Let's look at a real-world example. A global buyer once rejected an entire shipment of t-shirts because small holes in the fabric were discovered during final inspection. That led to delayed delivery, financial penalties, and damaged trust. Who's actually responsible for quality? The short answer, everyone. From the suppliers of raw materials to the stitchers, pressers, and packers. Everyone has a role to play. That said, quality inspectors play a key role. They are the eyes and ears of the QA process. They check samples, flag issues, and provide guidance to the team. Supervisors and production workers must also follow standard procedures carefully to avoid defects. Quality is truly a team effort. Let's look at some of the most common quality problems we see in textile and garment factories. Fabric defects, such as holes, stains, or incorrect colors. Stitching problems, like broken threads or skipped stitches. Wrong measurements, leading to poor fit. And finishing defects, such as loose trims or poor ironing. These issues might seem small, but when they affect hundreds or thousands of pieces, the cost can be huge. Here are a few key terms you'll hear often in QA. Inspection. This means checking a product to make sure it meets quality standards. Defect. Any problem or flaw that reduces product quality. AQL, or acceptable quality level, a method used to decide how many defects are acceptable in a shipment. QC, or quality control, the steps a factory takes to ensure products are made correctly and consistently. You'll hear these terms a lot in later lessons, so it's good to get familiar now. There are three main types of inspections you should know. 1. Raw material inspection. This happens before production begins. You check the fabric, trims, and other inputs to make sure they meet requirements. 2. In-process inspection. These checks happen during production, like during stitching or printing, to catch problems early. 3. Final inspection. This happens after production is complete, just before packing and shipping. Here's an example. If you catch a fabric shade variation during the cutting process, you can stop the defect from affecting hundreds of pieces, saving time, money, and your reputation. So, to wrap up, quality is everyone's responsibility. Understanding defects and inspections is the foundation of good QA. And focusing on quality at every step builds stronger products and stronger brands. In the next module, Principles of Quality Control and Inspection, we'll explore how QA systems are designed, the standards that factories follow, and who is responsible for what. Thank you for joining today's session. We hope you are enjoying this training course. Don't forget to like, subscribe, and hit the bell icon so you never miss a lesson. See you in the next lesson. Welcome to the virtual training course on Quality Control and Inspection. In today's video, we will focus on Lesson 2, Principles of Quality Control and Inspection. In this video, you will learn what is quality control or QC, what is inspection, the three pillars of quality control, inspection standards and AQL, also known as acceptable quality level, the key roles in the QC system, QC tools used in the garment industry, the benefits of a strong QC system, and the challenges you may face while implementing QC. Let's get started. What is quality control? Quality control, or QC, is the process of checking and verifying product quality at different stages of production. The goal is to prevent defects, not just find them. QC ensures that the finished product meets customer expectations and specifications. For example, if a QC inspector finds a stitch issue during the sewing stage, the problem can be stopped early, preventing mass defects later. What is inspection? Inspection is a step-by-step check to identify and record defects. Inspections are carried out at different stages, such as the raw material stage, like fabric and trims, inline, or during production, and endline, which is the final stage after production but before shipment. The three pillars of quality control are 1. Prevention, stop defects before they happen. 2. Detection, identify defects during production. 3. Correction, fix root causes and improve future performance. Inspection standards and AQL. AQL, or acceptable quality level, defines how many defects are acceptable in a shipment. Inspections are done using sampling plans. For example, checking 80 pieces out of 500. Defects are classified as critical, dangerous or unacceptable, such as a sharp object in a garment. Major, affects function or appearance, like broken stitching. Minor, small issues that don't affect function, such as a loose thread. Example: if a buyer allows an AQL of 2.5, then only 5 major defects are acceptable in 80 checked pieces. Key roles in the QC system. The QC inspector, who performs checks and reports defects. The production team, who are responsible for making the product correctly. Supervisors and managers, who analyze reports, take action, and train staff. And finally, the customer or buyer, who sets quality expectations and tolerances. Some common QC tools include checklists, customized for product type, measuring tapes, scales, and defect boards, fabric inspection machines, and inspection reports, daily or weekly. Here's a real-world tip. Always carry a checklist and a defect reference sheet during inspections. A strong QC system provides many benefits, such as fewer rejections from buyers, lower rework and waste, on-time deliveries, higher customer satisfaction, and continuous improvement in processes. Challenges in implementing QC. Of course, QC also comes with challenges, such as lack of training or awareness, poor communication between departments, pressure to meet production targets, and incomplete or inaccurate inspections. Some solutions include conducting regular QC training, using simple QC standard operating procedures, and encouraging teamwork between production and QC teams. Let's summarize what we learned today. QC and inspection are essential for ensuring product quality. AQL, checklists, and teamwork are key to success. And in our next lesson, we will explore fabric inspection, methods, tools, and defects. You'll learn how to check raw fabrics before they go into production. Thank you for joining today's session. We hope you are enjoying this training course. Don't forget to like, subscribe, and hit the bell icon so you never miss a lesson. See you in the next lesson. Welcome to the virtual training course on quality control and inspection. In today's session, we will focus on Lesson 3, Fabric Inspection, Methods, Tools, and Defects. By the end of this video, you will clearly understand why fabric inspection is important for quality and cost, when we should inspect fabric during production, the most common types of fabric defects to look for, how the 4-point fabric inspection system works, what tools are commonly used for fabric inspection, the step-by-step procedure of conducting fabric inspection, how to handle defective fabric rolls once they are identified, a real-world scenario to connect theory with practice, and finally, how to prepare and maintain fabric inspection documentation. So, let's get started. Why fabric inspection is important? Fabric inspection is one of the most crucial steps in garment manufacturing. Why? Because fabric makes up 60 to 70% of a garment's value. Once stitching begins, fabric defects become costly and difficult to fix. By inspecting fabric early, we can prevent cutting losses, production delays, and buyer rejections. Here's a real-world example. A shipment of shirts was once rejected due to visible slubs and stains. Later, it was traced back to fabric rolls that had not been inspected properly. When to inspect fabric? Fabric should always be inspected before cutting, after it has been received and allowed to relax. Inspection must be done for each lot, color, and supplier. Ideally, every roll should be inspected. But if that's not possible, at least 10% of rolls must be checked following a proper sampling plan. Let's look at some common fabric defects. These include knots, slubs, and holes. Shade variation. All stains or dirt marks. Misweaves or misprints. Selvage defects. And issues like skewing or bowing. All of these can seriously affect garment quality if left unchecked. The 4-point fabric inspection system. The 4-point system is the most widely used method to rate fabric rolls. Points are assigned based on defect length and severity. 0 to 3 inches equals 1 point. 3 to 6 inches equals 2 points. 6 to 9 inches equals 3 points. And more than 9 inches equals 4 points. A roll is considered acceptable if the total points per 100 yards is 40 or less. For example, if a roll scores 38 points per 100 yards, it passes the inspection. What tools do we use for fabric inspection? We need a fabric inspection table or machine with proper lighting, a measuring tape or counter, a fabric quality log sheet, and a 4-point system reference guide. Other useful tools include a GSM cutter for fabric weight testing and color lab or dye test tools, if required. Fabric inspection procedure, step by step. Here's the step-by-step inspection procedure. 1. First, relax the fabric for 12 to 24 hours before inspection. 2. Place the fabric on the inspection machine. 3. Inspect at about 45 yards per minute, checking both sides carefully. 4. Mark all defects visibly using chalk or stickers. 5. Record each defect and calculate total points. 6. Finally, tag or separate the rejected rolls. Tip: to maintain consistency, rotate inspectors regularly and always follow the SOPs. So what happens if we find defective rolls? We must inform the supplier immediately and request a replacement or credit. In some cases, non-critical parts like pockets or inner linings can be cut from defective fabric, but only if approved. Remember, never proceed to cutting with unapproved fabric. Here's a real scenario. One factory used fabric with hidden holes just to meet a deadline. Later, 20% of garments failed final inspection, resulting in a total loss. This shows why inspection is critical. Fabric inspection documentation. Fabric inspection is not complete without proper documentation. We prepare a roll-wise inspection report, keep a log of defect types and counts, and clearly mark the roll approval or rejection status. A summary sheet for each lot helps management and buyers review inspection results quickly. To summarize today's session, fabric inspection helps prevent many quality problems. Use the 4-point system, inspect fabric early, and maintain detailed records. In our next lesson, we will move on to garment inspection, stitching, measurements, and finishing. Thank you for joining today's session. We hope you are enjoying this training course. Don't forget to like, subscribe, and hit the bell icon so you never miss a lesson. See you in the next lesson. Welcome to the virtual training course on quality control and inspection. In today's session, we will focus on Lesson 4, Garment Inspection, Stitching, Measurements, and Finishing. By the end of this video, you will clearly understand what is garment inspection, stitching quality inspection, what to check, common stitching defects, measurement inspection, finishing inspection, Garment defect classification. Inline versus final inspection. Inspection procedure, step by step. Inspection reporting. What is garment inspection? Garment inspection is the final checkpoint before products are shipped to the buyer. It ensures that garments are safe, correct, clean, and presentable. Inspections can be done during production, at the end of the line, or as a final pre-shipment check. Here's a real-world example. A buyer once rejected 10,000 trousers because of inconsistent leg lengths and broken stitches, problems that should have been caught during final inspection. Stitching quality inspection. What to check? When checking stitching quality, focus on the stitch type and its consistency. Make sure the thread tension is balanced, not too loose or too tight. There should be no skipped stitches or broken threads. Backtacks must be secure at the beginning and end of seams. Also, check for neat trimming of extra threads. Common defects include open seams, uneven stitch lines, and raw edges that are not properly folded. Common stitching defects. Some of the most common stitching defects are broken stitches, needle holes, unbalanced tension, misaligned seams, and loose threads. Each of these can lower the quality and appearance of the garment. Measurement inspection. Garments must always match the buyer's specification sheet. Important points to measure include chest, waist, hips, sleeve length, inseam, outseam, and overall length. Measurements must fall within the buyer's tolerance levels. For example, if the spec is 100 cm with a tolerance of plus or minus 0.5, then the acceptable range is between 99.5 and 100.5 cm. Finishing inspection. Finishing gives the garment its final look. Check that ironing and pressing are done properly. Make sure there are no stains, all marks, or dirt. Verify that the size label, care label, and brand tag are correct. Also, check that garments are folded neatly, packed correctly, sealed in polybags, and that hang tags and barcodes are attached properly. Garment defect classification. Defects are usually classified into 3 categories. Critical defects are safety or legal issues, such as finding a needle inside the garment. Major defects affect the use or appearance, like receiving the wrong size. Minor defects are small visual issues, such as a loose thread. Inline versus final inspection. There are 2 main types of inspection, inline and final. Inline inspections help to catch defects early, during stitching, using smaller sample sizes. Final inspections are done after packing to approve the shipment, usually following the AQL sampling method. Inspection procedure, step by step. Here's the step-by-step inspection procedure. First, prepare the measurement chart and buyer's checklist. Second, select garments using random sampling. Third, inspect stitching and finishing visually. Fourth, measure each point and record the results. Fifth, classify and count the defects. Finally, accept or reject the batch based on AQL. Always remember, inspect under good lighting and have defect tags ready. Reporting. After inspection, fill out the inspection format sheet. Record the purchase order number, style number, defect types and counts, and the pass or fail decision. For major or critical defects, attach photos. Then share the report with your supervisor and the quality assurance manager. Summary and what's next. To summarize, garment inspection covers stitching, measurement, and overall presentation. Using spec sheets, checklists, and AQL helps ensure consistent quality. In the next lesson, we will explore in-process quality checks versus final inspections and learn how to catch defects early in the production line. Thank you for joining today's session. We hope you are enjoying this training course. Don't forget to like, subscribe, and hit the bell icon so you never miss a lesson. See you in the next lesson. Welcome to the virtual training course on Quality Control and Inspection. In today's session, we will focus on Lesson 5, In-Process Quality Checks versus Final Inspections. By the end of this session, you'll clearly understand what in-process quality checks, or IPQC, really mean, what final inspection is all about, why IPQC is more effective than relying only on final inspection, the most common checkpoints for IPQC, how to carry out IPQC step by step, the tools used for in-process checks, the key benefits of IPQC, and how to combine IPQC with final inspection for the best quality results. What are in-process quality checks? These inspections happen in real time while production is still running. The goal is to detect and correct problems early, before they spread through the entire batch. This saves cost, saves time, and avoids mass rework. For example, an inspector spots a faulty folder on a sewing machine causing open seams in just 2 garments. Fixing it immediately avoids 1,000 defective pieces. That's the true power of IPQC. Now, let's talk about final inspection. This inspection is done after garments are fully packed and ready for shipment. It's mainly used to approve or reject an order based on the AQL system. Final inspection checks stitching, measurements, appearance, and packing quality. So, why is IPQC more effective than relying only on final inspection? It's all about timing. IPQC happens during production, while final inspection happens after production is finished. With IPQC, defects are fixed immediately. With final inspection, it's often too late. Early fixes are low cost, while end-of-line rework is expensive. And most importantly, IPQC prevents problems from spreading, while final inspection only detects them. Remember, prevention is always better than detection. Here are the common checkpoints for IPQC. At the cutting table, is the fabric laid straight? Do parts match the marker? On the stitching line, check seam type, stitch count, and thread tension. For trims and attachments, inspect zippers, buttons, and snaps. At the finishing table, look for ironing quality, loose threads, and folding. And finally, at the packing station, verify labels, polybags, and size stickers. How to perform IPQC step by step. Here's how to perform IPQC step by step. 1. Follow the buyer's quality manual or your factory SOP. 2. Inspect random pieces from each batch or every hour. 3. Record any defects by operation or by machine. 4. Report issues immediately to the line supervisor. 5. Stop the production line for critical defects. 6. Follow up to ensure corrections or rework have been done. Tools used for in-process checks. These are the tools commonly used for in-process checks. Operation-specific checklists, tension testers or stitch counters, measuring tapes or gauges, red and green defect tags, hourly quality summary sheets, and a defect mapping board to track problems visually. Benefits of in-process checks. Here are the benefits of in-process checks. They reduce bulk rework, improve operator training and awareness, keep production running smoothly, help maintain consistent quality, and support a first-time right approach to production. Combining IPQC and final inspection, best practice. To get the best results, combine IPQC and final inspection. Think of IPQC as prevention and final inspection as confirmation. A strong quality control system always uses both. Daily meetings between QC and production teams help keep everyone aligned. And here's a practical tip. Use a daily quality dashboard to track defect trends and drive improvements. Summary and what's next. To summarize, in-process checks are critical for preventing mass defects. Final inspections are important, but they shouldn't be the only checkpoint. The best approach is to combine both methods. In our next module, we'll cover handling customer complaints and continuous improvement. Thank you for joining today's session. We hope you are enjoying this training series. Don't forget to like, subscribe, and hit the bell icon so you never miss a lesson. See you in the next one. Hello everyone, and welcome to the virtual training course on quality control and inspection. In today's session, we'll be covering Lesson 6, Common Defects and How to Prevent Them. This lesson is especially important because defects directly impact quality, cost, and customer satisfaction. By the end of this session, you'll have a clear understanding of why this lesson is important. The categories of defects. The most common fabric, stitching, and finishing defects. The difference between major and minor defects. The root causes of defects. How to prevent them using factory best practices. And finally, the role of preventive maintenance in ensuring quality. So, we'll be covering a lot, but everything is practical and useful for daily operations. Now, why is this lesson so important? Defects affect customer satisfaction, brand reputation, and even profit margins. A single defect that reaches the customer can damage trust in the brand. If we detect and prevent defects early, we save time, avoid costly rework, and prevent shipment delays. And, by knowing the common defect types, inspectors and supervisors can be more accurate and more effective in process control. Categories of defects. Defects can be grouped into three main categories. First, fabric defects, which come from the materials. Second, construction or stitching defects, which occur during sewing. And third, finishing and appearance defects, which happen at the end stages of production. Understanding these categories makes it easier to identify, prevent, and control issues. Common fabric defects. Some common ones are slubs, which are uneven thread thickness, knots or broken yarns that create weak points, color shade variations between batches, stains or dirt from oil, grease, or ink, and holes or snags from damage during handling. To prevent these, inspect fabric rolls using the 4-point system. Always store fabrics in clean, dry areas. Monitor dyeing consistency and lot numbers. And make sure proper fabric tension is applied during cutting. Stitching or construction defects. These include open seams where stitching isn't secured, skipped stitches that leave gaps, puckering caused by incorrect tension, broken or missing stitches, and sometimes even the wrong stitch type. To prevent these, use the correct needle size and thread. Maintain machines regularly. Check machine tension settings carefully. Conduct inline inspections at critical points. And ensure sewing operators are well trained in quality standards. Finishing and appearance defects. Finishing is the last stage, but it's just as important. Common appearance defects include stains or awl marks, wrong or missing labels, untrimmed threads, shiny marks from ironing, and incorrect folding or packing. Prevention here means keeping hands and gloves clean during final inspection, checking trims and accessories during packing, using pressing equipment correctly, following packing checklists, and verifying barcodes and size labels before the final pack. Major versus minor defects. Defects are usually classified as either major or minor. A major defect affects the product's function or appearance, and customers will reject it. For example, an open seam on the front panel. A minor defect is a small imperfection that doesn't affect the product's usability, like a loose thread on the inside seam. The key point here is, always follow the buyer's defect classification guide to make the right call. Root causes of defects. Now, let's talk about the root causes. Most defects can be traced back to poor raw material quality, insufficient worker training, machine malfunctions, weak supervision, or the lack of proper standard operating procedures. To really understand the root cause, use tools like the fishbone diagram or the 5 whys technique. These help us dig deeper rather than just treating the surface problem. How to prevent defects? Factory best practices. Some proven best practices are using visual SOPs at each workstation, providing daily operator training and feedback, carrying out inline inspections to catch problems early, auditing incoming fabric and trims before they enter production, and most importantly, ensuring strong communication between QC and production teams. Preventive maintenance for quality. Another key factor is preventive maintenance. Machines should be serviced regularly. Needle logs and maintenance checklists should be kept up to date. Correct machine settings should always be applied according to fabric type. And worn-out parts like presser feet, bobbins, and needles should be replaced without delay. Well-maintained machines produce consistent quality. Quality is everyone's job. Quality is not just the inspector's job. Preventing defects involves every person in the production process. From the fabric store, to the cutter, the sewing operator, the finishing staff, and the final QC team. If one step fails, the whole product suffers. Remember this quote: if we don't catch the defect, the customer will. Thank you for joining today's session. We hope you are enjoying this training series. Don't forget to like, subscribe, and hit the bell icon so you never miss a lesson. See you in the next one. Hello everyone, and welcome back to the virtual training course on quality control and inspection. Today, we are moving on to Lesson 7, Handling Customer Complaints and Continuous Improvement. By the end of this session, you'll have a clear picture of why customer complaints really matter. The common types of complaints we see in the garment industry. The complaint handling process, step by step. Tools for root cause analysis. Corrective and preventive actions, or CAPA. How to communicate effectively with the customer. The importance of continuous improvement. And finally, how to build a strong culture of quality and learning. Why customer complaints matter. Complaints are actually valuable because they show us where the gaps in quality are. But if not handled well, they can damage customer trust and our company's reputation. Unresolved complaints may lead to order cancellations, financial penalties, or even the loss of future business. For example, imagine a buyer reports that buttons are falling off after the first wash. After investigation, we discover the issue was caused by a missing bar tack at the attachment point. Common types of complaints in garment industry. In garments, the most common complaints include wrong size or fit, open seams or loose threads, color fading or shade variation, stitching defects, broken trims or accessories, wrong labeling or packaging, or the garment simply not matching the approved sample or spec. Complaint handling process, step by step. Here's how we handle a complaint. Receive and document the complaint. Acknowledge receipt to customer. Investigate the issue in production and QC records. Identify the root cause. Take corrective and preventive action. Reply to customer with action taken and prevention plan. Root cause analysis tools. To get to the root cause, we can use tools like the 5 whys method, asking why again and again until we reach the true cause, or the fishbone diagram, also known as Ishikawa, which categorizes possible causes into man, machine, material, method, measurement, and environment. For example, say we have a problem, broken zippers. Why? Because cheap zippers were used. Why? Wrong supplier. Why? No approved vendor lists. And there's the root cause. Corrective and preventive action. Corrective action is about fixing the current problem. Preventive action ensures the problem doesn't happen again. For example, issue, loose threads. Corrective action, reinspect and trim. Preventive action, introduce a thread trimming SOP and train staff. Issue, wrong label. Corrective action, replace the labels. Preventive action, use barcode scanning during packing. Communicating with the customer. When replying to a customer, always use a professional, polite, and transparent tone. Share evidence, like photos, inspection records, or action reports. And most importantly, show your commitment to preventing the issue in the future. For example, an email might say, "Dear, thank you for informing us about the issue. We've identified the root cause and implemented corrective actions. Please see the attached report for full details." Continuous improvement means regularly working to reduce defects and improve processes. It's about making small, consistent improvements using tools like quality dashboards, Pareto charts, Kaizen activities, and the PDCA cycle: plan, do, check, act. Building a culture of quality and learning. To build a strong culture, we should train our teams regularly, using past issues as lessons. Encourage open communication between QC, production, and management. Use real complaints as case studies during training. And reward teams when they achieve low defect rates. Here's a tip: start a monthly quality review session with both QC and production teams. Summary and what's next. To summarize, customer complaints are opportunities to learn and improve. Always respond quickly, professionally, and with clear actions. Use root cause analysis and CAPA to prevent recurrence. In our next lesson, we'll look at tools for quality control, like AQL, checklists, and SOPs. Thank you for joining today's session. We hope you are finding this training series helpful. Don't forget to like, subscribe, and hit the bell icon so you don't miss the next lesson. See you there. Hello everyone, and welcome back to the virtual training course on quality control and inspection. Today, we are moving on to Lesson 8, Tools for Quality Control, AQL, Checklists, SOPs, and more. By the end of this session, you'll have a clear picture of why QC tools are important, the key tools used in garment and textile inspection, AQL, or acceptable quality level. Inspection checklists. Standard operating procedures or SOPs. Defect classification sheets. QC logs and reports. Visual aids and samples. Root cause analysis tools. And finally, tips for using QC tools effectively. So, why are QC tools important? Well, they help us standardize inspections, improve communication between teams, and reduce mistakes or guesswork. They also make it easier to track and analyze quality performance over time. Remember this quote, "Without tools, inspection is just opinion." Let's look at the main QC tools used in garment and textile inspection. These include AQL, Acceptable Quality Level, checklists, SOPs, Standard Operating Procedures, defect classification sheets, QC logs and reports, visual aids, root cause analysis tools like fishbone diagrams and the 5 whys method. AQL, Acceptable Quality Level. What is AQL? AQL tells us how many samples to inspect and how many defects are acceptable in a batch. For example, for a shipment of 500 garments at AQL 2.5, we check a sample of 80 pieces. If we find 5 or fewer defects, it's acceptable. If more than 5 defects are found, the batch is rejected. AQL is mainly used in final inspections, but sometimes also in inline audits. Inspection checklist. Why use it? Because it ensures every inspector checks the same things, reduces missed steps, and creates inspection records. Typical items on a garment checklist include stitch type and length, seam strength, labels and size tags, loose threads, and even folding and packing. Tip: always customize your checklist according to product type. Let's move to Standard Operating Procedures, or SOPs. An SOP is simply a written document that shows the correct steps for doing a task. For example, how to inspect fabric rolls, how to check stitching quality, or how to pack shirts into polybags. SOPs reduce variation, make it easier to train new staff, and improve overall consistency. Defect classification sheet. Its purpose is to help inspectors categorize defects and define them as major, minor, or critical. Here's a sample. Open seam, stitch is broken, that's a major defect. Small thread left, not trimmed properly, minor defect. Wrong label, incorrect size or care label, critical defect. Tip: always align your defect classifications with buyer requirements. QC logs and reports. These are used to record defects, track inspection results over time, and communicate with production teams. Types of QC reports include daily inline reports, final inspection reports, and rework tracking sheets. The main benefit is simple: they make quality performance measurable. Visual aids and samples. These are photos, diagrams, or even physical garment samples that show what's acceptable and what's considered a defect. Why use them? Because they help non-readers or workers with low literacy, reinforce visual memory, and standardize judgment across all inspectors. Root cause analysis tools. When defects keep repeating, that's when we use root cause analysis tools. 2 common methods are the fishbone diagram, also called Ishikawa, which breaks problems into categories. The 5 whys method, where you keep asking why until you find the real cause. For example, a skipped stitch. 1 why? The needle broke. 2 why? Wrong type of needle. 3 why? No checklist. 4 why? No SOP. 5 why? No training process. And that's the root cause. Here are some tips for using QC tools effectively. Train both inspectors and line supervisors on how to use them. Update checklists and SOPs regularly. Share reports with production teams. Keep all tools in an easily accessible place. Thank you for joining today's session. We hope you are finding this training series helpful. Don't forget to like, subscribe, and hit the bell icon so you don't miss the next lesson. See you there. Hello everyone, and welcome back to the virtual training course on quality control and inspection. Today, we are moving on to Lesson 9, Quality Documentation and Reporting. By the end of this session, you'll clearly understand why is documentation so important. The key documents used in garment QC. Examples like fabric inspection reports, inline and endline checklists, AQL reports, size measurement sheets, and defect tally sheets. We'll also cover CAPA reports, daily dashboards, and of course, best practices in documentation. Why does documentation matter? First, it provides evidence of quality control. Second, it helps identify patterns or repeated defects. Third, it's essential for customer audits, internal reviews, and root cause analysis. And finally, it builds trust and transparency. For example, if a buyer requests a defect trend report before approving the next large order, good documentation proves your consistency. Let's go through the key documents in garment QC. These include fabric inspection reports, inline inspection checklists, endline inspection summaries, final inspection reports in AQL format, size measurement sheets, defect classification and tally sheets, CAPA reports, and daily or weekly quality dashboards, defect classification and tally sheet, CAPA report, daily weekly quality dashboard. Here's an example of a fabric inspection report layout. It usually includes fabric roll number, color and style, type of defect, such as hole or shade variation, location and quantity, and grading, often using the 4-point system. Now, about inline and endline checklists. They include operation-specific checkpoints like collar stitching or side seams, defects found, yes or no, quantity checked versus passed, inspector comments, along with time and date. And here's a tip, always use simple checkboxes and defect codes. This saves time and keeps things clear. The final inspection report. This is based on AQL sampling and usually includes style, PO number, and quantity, the sample size inspected, defects found by type, and the final pass or fail decision. Of course, it must be signed and approved by the inspector. Let's move on to the size measurement sheet. This compares the buyer's spec chart with actual measurements. For example, waist spec is equal to 32 inches, tolerance plus or minus 0.5. If your measured result is 32.7 inches, it fails. Clear marking of deviations is a must here. Now, the defect tally sheet and Pareto chart. You record total quantity inspected, along with defects by type. Then, you create a Pareto chart to highlight the top 3-4 common defects. This makes it easy to set priorities for improvement. The Corrective and Preventive Action Report, or CAPA, is very powerful. It should include a clear problem description, a short root cause analysis, the corrective action taken, preventive measures planned, who is responsible, and the deadline, and of course, follow-up results. Tip: always document who is responsible and by when. Now let's talk about daily and weekly dashboards. These are often created in Excel or QC software. They show daily defect rates, line-wise quality performance, rework percentage, and first pass yield. Dashboards help management quickly see trends and take action. Best practices in documentation include using standardized formats, making sure reports are dated, signed, and properly stored, training inspectors to fill reports accurately, backing up digital files and auditing physical records weekly, and reviewing reports during weekly continuous improvement meetings. So, to summarize today's lesson, good documentation ensures visibility, consistency, and improvement. Don't just keep documents for the record, use them for decision-making. In our next and final module, we'll talk about creating a quality-first culture in garment production. Thank you for joining today's session. I hope you are finding this series helpful. Don't forget to like, subscribe, and click the bell icon so you don't miss the final lesson. See you there. Hello everyone, welcome back to our virtual training course on quality control and inspection. Today, we are moving into Lesson 10, Building a Culture of Quality, Training, Audits, and Improvement. This is one of the most important lessons because it connects all the tools we've learned so far with the mindset that keeps quality alive every single day. By the end of this session, you'll clearly understand what a quality culture really means, why culture is more powerful than just having checklists, how to build culture through effective training, how to run quality audits, why involving operators is critical, and finally, how to measure progress with KPIs and overcome common challenges. So, let's get started. What is a quality culture? A quality culture means that everyone in the factory, whether an operator, a supervisor, or a manager, feels responsible for quality. They are empowered to stop defects, focused on preventing problems instead of fixing them later, and they see improvement as part of daily work, not just an extra task. Why culture matters more than checklists. You can have the best tools and SOPs in the world, but they won't work if people don't believe in quality. When a factory builds a quality mindset, defects go down, morale goes up, and costs are reduced. Strong cultures solve problems faster, get fewer complaints from customers, and even attract better buyers. Culture is not just soft talk, it's good business. Quality training, the first step. The first step to culture is training, and it must reach all levels. Operators need awareness of defects and basic QC skills. Supervisors must learn problem solving and how to track defect data. Inspectors focus on root cause analysis and clear reporting. And management needs to understand KPIs and how to lead teams. Training can be done during onboarding, through monthly refreshers, or even quick on-the-job coaching sessions. How to run effective quality trainings. Good training is not about long PowerPoints. It's about keeping things simple and visual. Use real examples from your factory, give people hands-on practice like defect spotting, and always provide feedback afterwards. One practical tip. Set up a quality corner board where you post visual guides, updates, and training plans so learning stays visible. Internal quality audits. Internal audits are like self-checks, a way to confirm if processes are being followed. Audits should look at process control, SOP compliance, defect trends, and equipment maintenance. They can be done weekly or monthly, and the team should include QA, production, and compliance members. Audit format, what to include. Every audit needs a clear structure. Which department or area was checked? The audit date and auditor's name. a checklist of items, observations and photos, a non-conformance report, and an action plan with a review date. This ensures follow-up actually happens, not just paperwork. Involving operators in quality. A culture of quality must include operators. Teach them to check their own work and reward zero-defect achievements. Give them the authority to stop the line if they find a big issue. And promote quality champions every month. Here's a real example. One sewing line cut broken seams by 70% after operators were trained on thread tension and given small incentives for perfect runs. Continuous improvement, a long-term habit. Culture doesn't happen in one day, it's built through daily habits. Tools like Kaizen help with small, daily improvements. The PDCA cycle keeps change systematic. Gemba walks bring managers to the floor to see reality. And quality circles give small teams the power to solve problems together. Key performance indicators to track culture progress. How do we know culture is improving? We measure. Track defect rates per 100 pieces, first pass yield, rework rates, customer complaints, training hours, and audit scores. These numbers will tell you if the culture is really shifting or if it's just talk. Challenges in changing culture and how to overcome them. Of course, culture change is not easy. You'll face resistance, blame games, and poor communication. The solution is leadership. Managers must set the example, encourage open discussions, and reward positive behavior. Change sticks only when people see leaders walking the talk. Summary: what a quality culture looks like. So, everyone is trained. Quality is checked at every step. Mistakes are fixed without blame. Improvement is part of everyday work. And leaders actively support and reward quality. Remember this powerful quote by Henry Ford. Quality means doing it right when no one is looking. Thank you for joining today's session. I hope you now have a clearer understanding of how to build and maintain quality control and inspection in a factory setting. If you found this session useful, please share your feedback so we can keep making the training better for you.